Good afternoon and welcome to the July 7th edition of the Tuesday webinar series. Today's webinar is titled Telemetry and Data Analytics. I'm Will Stradling of Siewert Equipment. Just a few housekeeping items before we begin. During the presentation, there will be 4 multiple choice questions to answer by poll vote. You will click on the answer you think is correct. We'll post the results and move on. To receive your operator and PE credit for this webinar, you must complete the poll questions during the presentation. If you run into technical problems with answering the poll questions, try 1, not maximizing your screen, or 2, write down the answers and email them to Sherry. In addition, please feel free to type in your own questions anytime in the questions drop-down arrow, and we'll do our best to answer them at the end as time allows. To receive your PE credit for this webinar, you must also complete the evaluation. You'll stay connected and the evaluation will pop up at the end. You'll also need to download the certificate of completion and PDF of this presentation. These are available under the handouts drop-down arrow. Download them anytime before the end of the presentation. If you miss downloading these, contact Sherry and she'll attach them to the follow-up email that she sends you. Well, that wraps up the announcements. I'd like to introduce Jim Welsh of Siewert Equipment as our presenter. Please follow us on Facebook and LinkedIn. And thanks, enjoy the webinar. Go ahead, Jim.
All right, well, good afternoon now, guys, that it's just afternoon. Bear with me, I might be a little bit out of practice with this. I haven't done too many since I've been here at Siewert Equipment. In a past life, I spent the better part of a decade at a pump company, Environment 1 over in Niskayuna, where we did presentations like this quite regularly for a myriad of different topics. Telemetry has always been something that I've been passionate about, as well as data analytics. We're also going to talk a little bit on SCADA as well. Now, today's webinar is going to be about an hour long, a little less, and you guys are all muted, so please definitely jump in, add questions as we go. Will be reading them as they come in. That way we can kind of pause the presentation and answer your guys' questions. The big point of today is not to teach anything specifically about any version of SCADA or telemetry. There's tons on the market. I encourage you guys all to go out and do your own homework, and I'll help kind of guide you into hopefully what's going to be best suited for your specific needs, be it single family residential all the way up through full plant control. So bring the questions in anytime you want. We'll pause, we'll answer them. And again, this is just going to be more of a conversation. Feels like one way, me talking to you guys and you typing the questions in, just showing you the possibilities of what SCADA and even just basic telemetry can do for your organizations, your outfits, your departments. So today we're going to start off with just a pretty cookie cutter intro definitions of SCADA, telemetry, and analytics, why it's important to every outfit, not just the full munis, the full plants and systems, all the way down to the single homeowner. There are limitations of both telemetry and SCADA, so we're going to touch on those as well, give you guys things to consider when you're selecting a system that works for you. We'll talk quickly about a basic component overview, which system should you choose depending on your eventual goals and expectations. When we have the system in place, that's when the real fun starts. We're going to get to see the data and figure out how that data can help us. The hard part's interpreting it, figuring out how to make sense of all of the possible data that can come in. A couple examples of some basic analytical processes that can show how powerful even the little stuff is. Bulk report analytics, again, this could be something that is done in-house or it could be farmed out to a data warehouse. Again, the amount of data that you guys can have access to through a system like this is enormous. And then sorting through it could either be done in-house or out. And then lastly, notification management. So this type of system, both telemetry and SCADA, can be considered both reactive and proactive. Far too often in my last decade in the water and wastewater sector have I seen individuals and full organizations look to a system like this for its purely reactive benefits. an alarm goes off somewhere, a door opens somewhere. That triggers an input-output signal, goes to a phone, an email, a voice, and we tell you, hey, this just happened. When that's just barely scratching the surface of the power of a system like this. Predictive analytics or proactive planning of maintenance events or scheduling downtime more efficiently. So that's the rough agenda. We're targeting about an hour. If we finish up a few minutes early, that just hopefully gives more time for us to bang out any last questions that may be sliding in through the chat boxes. So the first real slide of the day is definitions. So just kind of, like I said, cookie cutter intro, getting you guys familiar with what we're talking about today. So telemetry, this is the most basic version of a system. It's pretty much pure monitoring. It's a collection of measurements or other data at remote or inaccessible points, generally referred to as like an edge, and the automatic transmission to receiving equipment for monitoring. Bad joke incoming. It's like that commercial where there's a security monitor at a bank, and he's just watching a break-in happen, and he's telling people about it, and he goes, I'm just a monitor, I'm not a security guard. Think of monitoring telemetry just like that. It's not going to run any piece of equipment in the plant or at a home. It's just going to tell you when a status has changed. Even with telemetry, we can use the historical information to begin to plan what we think might be happening in the near future, be it a pump's operation is from a seasonal occupancy, and we see high usage points and low usage points. We can plan how many cycles we're expecting to see, what capacities are going to be, and potentially make changes ahead of time to ensure the system is capable of accommodating an increase in flow or an increase in usage. The next step above telemetry is SCADA, supervisory control and data acquisition. So it's a pretty fancy name, abbreviation is a lot easier. It's more than just equipment inside of another piece of equipment, be it PLCs or controllers inside of a panel. It's more than just solenoids or things that are monitoring door position, valve position, temperature, humidity, pressure. There's a ton of different things that SCADA is capable of monitoring. It really depends on the amount of signals that you have access to, be it the analogs, the digitals, the inputs and the outputs. That I've seen in plants across the country using SCADA for so much more than what I expected them as water or wastewater entities to be using them for. So it's a control system architecture comprising of computers, network data communications, and the powerful part, the graphical user interface. You can see the screenshots that I've got up there. The top left or middle left, that is something very common that I've seen in larger municipalities, larger wastewater and water plants across the United States. And I mean, they do everything from tracking trucks, their service vehicles, the position of panel doors, what valves are open and shut, what booster pumps they have running, feed pumps they have running. Then in truth, most with a system this advanced, short of the boots on the ground in the field, can run the vast majority of their plant from inside a nice air-conditioned office. Back to the definition of SCADA, this also uses, like I said, peripheral devices, PLCs, discrete proportional integral derivative controllers with process and plant machinery. So little bells and whistles that get plugged into equipment across the organization, the plant, your system as a whole, that all feed into this system, the supervisory data acquisition system that allows an operator or a group of operators to decide how they want to configure a system remotely and make changes real time while receiving updates as to performance, temperature, flow, and I mentioned it a couple times already, silly things like the position of a door, which from a safety standpoint, a panel door being opened is huge. Even a low voltage, low amperage panel that's open in a rainstorm can cause catastrophic problems for a plant and an outfit. So that is collecting a ton of data. It's allowing operators to make changes real time, to potentially dispatch personnel into the field. But we're also getting a ton of data back that we might not be doing anything with directly. And this is where the analytics piece comes in. This is the discovery, interpretation, and communication of meaningful patterns in data. The patterns part's interesting. So everybody's heard the term big data these days. I mean, if you I've watched any golf channel. There's all the big IoT sponsors on golf. And what's the point of big data if we're not going to do anything with it? What's the point of paying for all of this data if we don't need all of this data? And we're going to trickle into that a little bit later in this presentation and hopefully educate you guys on finding a system that you can tailor to the needs of your organization without spending too much money, getting the data that we need in order to make the best use of it. The pattern part, again, is where we start to look at predictive analytics. More than just reactive, analyzing data. If you have capable and trained personnel understanding the system as a whole and seeing what data is coming in, even if they can't do it themselves, they can work with somebody that's going to allow them to look at this large chunk of data and potentially figure out what may be happening in the next week, month, or even longer than that. This way, instead of having a Sunday night service call or a Sunday night line break, big emergencies, sewage everywhere, we can plan for a Friday afternoon downtime, go out, do the work before it becomes an emergency. So bottom of the slide, the primary benefit of telemetry, SCADA as a whole, is the ability of an end user to monitor the state of an object or environment while removed from it. Once you've shipped product, you can't be present all the time. Even working in the community that you live in, you can't be there 24/7. Well, this equipment can. This telemetry and SCADA system allows insights to be delivered directly into a dashboard, potentially customized for you, each user, or for each outfit, that you guys can then choose whether to act on immediately or park it for a better time that more suits your guys' current state of business. Because it provides insights into how well the product is working for you as an end user, it's incredibly valuable for monitoring ongoing performance and to manage your system accordingly. All right, so we're going to have our first poll question here. Will, take it away.
Thanks, Jim. What does SCADA stand for? Please choose A, B, C, or D. Okay, about a little over 90% of you have voted. Gonna keep it up for a couple more seconds. The answer is A, supervisory control and data acquisition. Back to you, Jim.
All right. Well, I really had some other super funny 4-letter acronyms, 5-letter acronyms for SCADA, but most of them were inappropriate. So hopefully those weren't too awful for you. The next slide we're going to be talking about is why is it important? We kind of touched on that already, just in the definitions in the agenda slide. These are just a few examples that I pulled up, a couple from my background, and the one in the middle, the infiltration from an 18-inch line. I thought that was incredibly interesting, especially considering the plants that I've had an opportunity to work with over the last decade. We'll start with just the one on the left, I&I. And in many cases, I&I accounts for 45% of the annual flow to treatment plants. That's just a mind-boggling number. Exceeding the capacity of these collection systems results in discharge of contaminated water into the environment. So EPA violations, big fines, big dollar money. It also limits how large a system can grow. If we reduced I&I, then that might mean the system can accommodate more homes, more buildings, more businesses in the area without having to drop a ton of tax money or a ton of federal grant and local money into expanding the system just so we can handle the I&I and potential expansion of a community. The discharge may come from collection system components or from a treatment system that doesn't have the capacity to treat the water itself. It can also be caused by pipe structure failures due to erosion, soil support, and ground subsidence due to soil erosion itself. The sump pumps and laterals, so I got 9% up there at top. Infiltration in an 18-inch pipe is caused by a crack leaking approximately 8 gallons a minute. So this is just a hypothetical scenario that is actually from a real municipality across the country. And that equated to around 4.2 million gallons per year. It's about a little over $10,000. Residential sump pumps and foundation drain lines are sometimes improperly hooked up. And a single sump pump can send more than 7,000 gallons of water to the system during rainfall events. That's the same as 18 homes. That is an incredibly large amount of water and money wasted, not to mention capacity. And fortunately, this is just rainwater. I mean, if this was a wastewater line and we have a crack or a leak and we're losing that, again, that's a ton of raw sewage being discharged into the environment. And I know that certain areas have certain reporting capacities that they're required to do in terms of how much spillage. While we're on this one, another thing that I wanted to talk about is just a scenario that I ran into a while back. A single-family home in Connecticut had a roof drain tied into a grinder pump station, and they called up the actual distributor for the equipment, and the distributor asking if we could come out and do service. The homeowner's all cranky, no, we don't want you guys to come out. It's going to cost a ton of money. Well, we can't help figure out the problem if we're not there. Eventually, they allowed a telemetry system, nothing fancy, no control, just monitoring system to be installed. And the monitoring system was in for 2 weeks. And in that 2 weeks, it rained 3 days. And during each rainfall event, the high level alarm kept tripping. We were able to trace the pattern to the rainfall events. We presented the data to the homeowner, and they finally agreed to let the distributor come out. The distributor came out again, and right there, right on the back side of the actual cover itself, kind of buried, so it was difficult. They couldn't see it during the actual panel install where they had installed the telemetry equipment. There was a roof drain tied directly into their tank. And every time it rained, the roof drains funneled all that rainwater through the downspout into the tank itself, obviously overwhelming the capacity of the tank, causing high level alarms. That's just one instance of an improperly installed system with a cranky homeowner. Obviously, nobody wants to spend money that they don't have to. And telemetry was able to identify a pattern. The pattern provided data to the customer, and the customer then can't really argue with data. It's not a person providing an opinion or a suggestion. It's, this is what your system has been doing over the past 2 weeks, and here's what it lines up with. Would you like us to come out now? And of course, the homeowner was a lot more agreeable, came out, we got it fixed, and that homeowner became a good bit happier with the service provided by that specific distributor. Another instance, we were doing startups on low pressure pumps down in the Florida Keys, and there was big seasonal community. There's no residents actually at this home. The house had probably been built within the last 2 months. Everything was pretty much tied in. The home was ready for occupancy. And we installed the advisors along with the panel and the stations itself. Well, at night we were going through, rolling up the activations, activating the actual cellular modems. And once we did that, we'd make sure that specific events triggered to prove that the activation was successful. And we noticed that 2 or 3 of the systems seemed to be cycling, which wasn't out of the ordinary. Some of the homes were actually occupied, some weren't. Well, we found a single home that seemed to be having run cycles every 8 minutes, which, all right, that's a good bit more than we would expect a single family home that's fully occupied to be. The kicker was nobody was living there. There hadn't been anybody that had moved in yet. We brought this up to the attention of the builders, the contractors. They went out, just did a little bit of peeking around and found that they had a leaking toilet. One leaking toilet was capable of causing the pump to run every 8 minutes. So this specific pump is intended to cycle every 8 gallons. So this leaking toilet was putting a gallon a minute down into the tank, causing a cycle every 8 minutes. Now, it had been doing that for the better part of a month. The advisor was only hooked up for just over a day. We reviewed the data the following day and were able to help get the contractor on site and correct the issue. Again, very basic. We weren't even looking for the problem. The problem just showed itself. And last up, there's a community in Lake Washington, Minnesota, that was using telemetry to identify force main settling and blockages from a specific amperage report that was generated from the telemetry system. And this allowed them to narrow down what part of the actual force main was experiencing the blockages to about 30 feet, which for them, only having to excavate a 30-foot section as opposed to, I think the block was actually Mustang Drive or something, and the block itself had to have been a quarter mile. So excavating just 30 feet instead of having to potentially and systematically dig up chunks of lateral line in front of every home, we instead allowed them to see the benefits of the system by figuring out between which two homes were we noticing the amperage spike and then an amperage fall off where there was no obstruction. And this saved them a ton of money and a ton of time just doing dirt work. Again, they've been using the system for quite a while, and I have a bunch of other statistics from them that I would love to share with you guys. And again, don't hesitate to type questions in if you wanted to talk more about this later. We could definitely go into detail of specific systems. I'm going to try my best today to keep brand names and manufacturers out of this, because again, the intent here is just education. I want you guys to open your eyes to the benefits, the values that telemetry and SCADA can provide. Last up on this slide is an increase in product life. Using a telemetry system, SCADA system as well, the end user is able to receive real-time notifications, alerting them to changes in performance. So I have pumps up there, but it's so much more than that. The example that I'll use is just a run dry alert. So run dry, for those who aren't familiar with it, is a wattage event, a low wattage event specifically. And in a certain style pump, a low wattage event means one of two things. The pumping mechanism as a whole has lost its strength. It's worn out and it's not moving any fluid. So the pump is running continuously, not taking any fluid with it. That creates heat, and heat creates a premature failure. The other scenario for a run dry event or a low wattage event would be a siphoning scenario, where same deal, we're not getting any fluid through the pumping mechanism and out the discharge. So we're building up heat just a little slower in that instance. In this case, the homeowner made a phone call to a local and educated service outfit, and the service provider instructed the customer to turn the pump off. Doing that based on the run dry alert received to the homeowner by text message. And in this case, the homeowner that was monitoring it wasn't even in the same state. His wife and children were home. He was not. He got the message. He called the outfit called the homeowner up. He called his wife. They shut the power down. And a run dry on this specific pump, if it was a full motor rebuild, we could have been looking at new pump replacement plus install costs pushing $5,000. If we caught it fast enough and we still had to come out there and do any lower end work, that still would have saved them at least $1,000 on this call. And to an individual homeowner, that's big money. I know from a municipality and a treatment facility, a plant, that isn't a crazy amount to be talking about, but have that for every single home in a system, and we could be talking a very large amount of money. The end of the day here, one notification triggered by a telemetry system was enough to allow a homeowner to talk to a service provider and save the pump from any additional damages that may have happened past what led to that run dry alert being created. So the bottom sentence below circles back to how much more a telemetry and a SCADA system can actually provide for you. On factories, buildings, and houses, energy consumptions of systems such as HVAC are monitored at locations. Related parameters, the temperature, pressure, those are all monitored and sent wirelessly back to a telemetry system at a central location. And again, that information is collected, processed, enabling energy efficiency. We can also tie in rain gauges, we can tie in door sensors, we can tie in pretty much anything that we can monitor into a telemetry or a SCADA system and provide an educated operator a chance to see it and interpret it meaningfully, and then make a decision as to, is this good to ignore for now? Is this good to ignore forever? Is this in spec parameter, or is this something immediate that needs attention now? Past that, it also gives operators a chance to look at those readings over a period of time, a month, 2 months, 3 months, and look at the trend. Is it trending in a way where we might want to proactively go out and inspect this given piece of equipment because it tripped some sort of a soft alert for a sensor, be it temperature, pressure, humidity, wattage, run cycles, run times, who knows? Again, the operator at that point is empowered based on the data received from the system, and all of that together creates a scenario where the plant, the department, the outfit is able to run more efficient. Now, that was, feels like I was on a soapbox preaching about the benefits of systems like this, but we also have to consider the limitations. And again, this is meant to be just an eye-opening conversation for you guys. A lot of people that I've interacted with don't know much about telemetry and SCADA in the wastewater world specifically. My previous employment with Environment One, we didn't do a lot on the water side. So wastewater-wise, I got a chance to talk to a lot of service providers and local municipal operators, and some have heard telemetry, have heard about SCADA, but don't know much past the name, or that it checks on some equipment while they're not there. So I want you to take away both the goods and the bads from this. Everything has a flip side, the other side of the coin, and if you're not paying attention to it, it could bite you. Something simple in telemetry typically requires power. So if you're monitoring equipment and that piece of equipment loses power, that's going to be an interruption in data transmission. You're going to lose the ability to see that piece of equipment remotely. Some telemetry systems and SCADA systems will come equipped with like a battery backup, and don't let that make you think that that battery backup is capable of running this piece of equipment. Generally, what it does is it allows the piece of equipment that's providing the monitoring to send out a single message. That message would be power loss, power failure, power interruption, some sort of message to trigger you to know that you've lost your voltage source to this piece of equipment. They're able to communicate in a myriad of different forms: radio mesh, cellular technologies, be it 3G, 4G. Right now, 3G should be dead in most parts of the country. I think Verizon may have extended their 3G signal until the end of this calendar year. But for all intents and purposes, 3G shouldn't even be looked at as a viable option at this point. It should be going 4G LTE or something higher, broadband. There's also hardline, which in most instances, hardlining is difficult, especially if the square footage, the footprint of your plant is large. That's just a lot of line to run. And having physical lines obviously provides an opportunity for those lines to be damaged. But with all of that, it's important to consider what works best in your area. Snowshoe, Pennsylvania, they started out as a radio mesh, and it was great when the homes were just freshly built. The trees were nice and small. They had the repeaters put at the proper locations, and signal traffic was great. Everything was bouncing the way it was supposed to. Fast forward a few years, trees are in bloom now. The operators are constantly back out readjusting their repeaters so they can get this radio signal to bounce to the collection devices. So radio mesh is great. It's a little bit cheaper, at least in terms of the individual repeaters. The main stations, the main collection devices have a pretty price tag, at least from the last time I did any homework on them. But again, they have their purpose and they have their place in an area with low amounts of foliage, trees, bushes, plants, maybe southwest. They would be great. In the Northeast, cellular is what I've seen take more of a foothold, just because, again, we're, at least in the area where we're at, Troy, Schenectady, Albany, Saratoga, cell coverage generally isn't an issue. Even in the surrounding municipalities, the cell signal is typically strong enough. And again, we're not trying to send 4G HD cat videos through these modems. We're just trying to send an individual message, one byte, one packet of information at a time. And that can be multiple times over the course of a minute, but none of them are very large at all. So in areas of weak or limited coverage, I've seen people go to satellite, and again, that's also an expensive proposition. Just use this as one part of your consideration as to which system might be best suited for you. They're all viable technologies, and certain telemetry and SCADA providers only offer certain forms of communication. So keep that in mind as you're moving forward. The excuse me, the UI, so that stands for user interface, processing power, and quantity of inputs. These are all other things to consider in terms of the system that you're going for. Not all telemetry systems are created equal. You are going to get what you pay for. Now, we talked about it a little earlier. We don't need to pay for the super deluxe everything if we don't plan on using it to its fullest potential. You can buy SCADA packages and telemetry packages that can literally accommodate anything, and the price tag is astronomical. We also need to think about how much we need in terms of like minimum quantities, because there might be a system that's perfect in terms of what you're looking for, why you're targeting this type of system. So certain telemetry systems and SCADA systems may limit the number of inputs you have. So inputs, in one version of telemetry, we have 5 analogs and 2 digital. So each individual cellular modem can handle 7 different inputs, 7 different events: an alarm event, an alert event, a high level event, a power loss event, a cellular inactivity. We just burned 5 out of the 7 with what I just said. The other 2 could be maybe rainfall, maybe humidity. There are other pieces of equipment that can handle much more inputs, be it analog or digital. And again, the more you pay, the more inputs you're going to have access to. So we have access to however many inputs we chose to buy. Now you have a user interface, and that user interface is being fed information from a computer bank, the bank of servers. And that server bank, that's the brains. It needs to have processing power. Otherwise, all of this data coming in could be too much for the system, could overwhelm the system, or it could limit how much data you can hold in the system for any length of time. At my previous employment, we had 2 versions of a telemetry system. Our original version, we called it the 1.0. We used it for the better part of 4 years. The first couple years of use and implementation, we didn't have many units in the field out communicating with edge devices, and we could hold every piece of data that came in from every single cellular modem in perpetuity. As the years started going by, more systems started being brought online, and the amount of data we were collecting was growing exponentially, to the point where we actually had to turn off certain features and certain data streams from these devices because the actual operators accessing the website weren't able to download the data. It was erroring out, runtime errors or server communication issues. And that was due to us making a request to the system. You try to download something, it reaches out, and it only has a certain amount of time to get that info. If that amount of time elapses, then it shuts the whole download down and you lose everything. So having processing power, again, is important. We need to know what data we're looking for, know how that system is going to be growing over the next 1, 2, 5, or 7 years, and figure out what style system is going to work best for us. How many inputs? How strong does the server bank need to be? And how much data do we plan on pulling off or holding at any given time? Now, past that, another consideration is the reporting itself. So we talked about the reactive reporting. That's pretty easy. I've seen a number of munis across the country ask for like monthly flow reports because they have to report out to an EPA or something. Those archived reports, so we can store that data either inside of the original system or it can be hosted somewhere else, a completely different website that we just use as literally a data warehouse. We reach out to it, download what we need, and then that's completely disconnected from the main system. If you wanted real-time reporting, again, that's constant back and forth data traffic. That's burning up resources in the system. So knowing your reporting needs, both upfront and long-term, are going to help figure out how we handle the growth or expansion of an existing system. Last up on limitations is security. Now, I call this a limitation for lack of a better term to describe it. With everything being so heavily focused on the internet, with servers and computers these days, security is becoming more of a big deal. It should always have been, but back in the day, older systems of this style were kind of built as closed loop. The only people that would have access to the system, because it was all hardlined, were the people inside of the building. There was no outbound data traffic. There was nothing going to the cloud or to public servers or even VPNs that are stored somewhere else across the country. There are a ton of articles out right now that discuss SCADA system vulnerabilities and evolving threats. So I'm going to park right here and talk about the difference between telemetry and SCADA. It's really one word that separates them. SCADA is control. Telemetry is monitoring. If somebody hacks into a telemetry site, they can't control anything. They may be able to lock the site down. They may be able to prevent people from viewing their own data, but they're not turning pumps on. They're not shutting valves. They're not hurting the system because it's literally one-way traffic, view only. Think of it as read only. With a SCADA system, if somebody found their way into a SCADA system, they can turn on and off key and integral components in a plant, in a wastewater or a water facility, and potentially shut down water to an entire community. They can create a situation where they build pressure in a pipe and burst a line, spilling water, spilling waste. That there's a ton of things to consider. And the good news is most of the bigger name SCADA systems, and even the little guys that are having to go through any sort of an audit or a securities control process, understand that these vulnerabilities can occur and they are there. And they're at least working with the experts to figure out how to stop them or minimize the potential impact that they can create. So ultimately, the fight against these exploits means being vigilant. Every operator, every owner, every person and part of the system needs to have some sort of monitoring to it. We need to make sure that only the people that are allowed to have access to specific areas. Segregation of duties is always a very, very smart thing to do. And if this is, I'm going to call it turnkey, if you have somebody else building this system for you, they need to be monitoring it, applying patches to fix newly identified vulnerabilities and potential issues that may occur. And aside from these vulnerabilities, organizations themselves must maintain measures that can defend against these attacks. Password management, don't share your passwords. Don't share your logins. When you have turnover inside of a facility, make sure that that person's access is immediately removed. We never want to think of the bitter ex-coworker that is a little bit jaded and manages to still somehow have access to a system. You shouldn't, or she. But even past that, when you have that sort of scenario, the vulnerability exists and somebody could make their way in. And I know I live in Glenville, and I would hate to see my water turned off in Glenville or lose access to flushing toilets because for whatever reason a valve got shut off, a pump got turned off, and now I'm out of water, out of luck. So keep all these things in mind. There's a ton of good that can come of monitoring and of control of SCADA, but there are also things that we know we're going to be walking into: power losses, processing power, and security. And keeping those things in our mind is going to allow us to think about what we need and what we're getting ourselves into so we can pick the proper system for what we're trying to do. Now we'll turn it up to Will again. Question number 2.
All right, I'm going to launch the poll. Which 2 answers are common limitations of SCADA telemetry? Please select A, B, C, or D. Okay, over 80% of you have voted. I am going to close the poll. The answer was B, power loss and security. Back to you, Jim.
All right. So I'm looking at the time and it's already 12:40. So there's a couple of slides that we're going to move through a little quicker so we can get to the fun stuff. So this is a telemetry system and even a SCADA's basic components and functionality. The screenshot on the left, the hardware. So you see a SCADA pack in the top right-hand corner. You see a group of PLC logic-based components in the middle right. Below, you kind of see an example system where we've got an edge device, that telemetry transmitter, potentially a data logger. You got a receiver somewhere, and you got your server bank feeding it to computers. be it hardwired, wireless, however you want it. This shows antennas. Top left, we see a panel with a cellular modem style transmission device. And again, these are all just real-time data capture and transmissions via whatever source of provider you choose to use, the 4G, radio mesh, satellite hardline. And then on the right, everything should be feeding into some sort of a user interface. And what we're looking for is a design that focuses on anticipating what you guys need, not what the provider thinks you might need. This is where communication has to be a two-way street. And again, my previous life, we learned the hard way. If you don't know what you're looking for, then you're trusting somebody else to help you figure out what's going to make the biggest impact in your system when they don't actually know what you have. So doing the homework on your guys' end is going to help you figure out what the purpose of providing a system like this would do for you, and then feeding that information to the people designing the interface, to the partner that you choose to work with. All right, question 3.
Okay, I'm gonna launch the poll. What are the common types of data transmission? Choose A, B, C, D, or E.
And if you guys can still hear me, it's definitely not snail mail.
No, we're on 3. Okay, almost 90% of you have voted. Give it a couple more seconds. E, all of the above. Back to you, Jim.
All right. So now we start talking about what system to choose. And really, to do that, we need to understand what you're looking for. Are you looking for correcting existing issues? Is this a choice you're making because you know that you're having issues with infiltration, with pressure transients, with line breaks? Or are we looking at a system like this to plan for future enhancement? We don't want to spend the money on increasing the size of a plant. We want to use this to minimize I&I, find the failure, correct it, reduce the total flow coming in per day. That way we have the room to grow the system without spending the money on enhancing the size of the plant. Are we doing this to better plan schedules? Are we running thin on operators and now we need to figure out how to manage a schedule? We need to minimize the amount of nights and weekends calls, and we want to be more proactive as opposed to reactive. All these things are going to factor into which style system to choose. The number one on the list is do it yourself versus a kit or a turnkey. So turnkey, that one has been looked at a lot by a few different outfits that I've worked with. Again, the hard part here is there is a lot of upfront work that goes into a turnkey kit. You have to spend the time educating the vendor, the provider, on what you need. You almost have to turn them into an operator. Otherwise, they won't understand where you see the value or where the value could be. The do-it-yourself. Now, this is just like in home building projects. Do-it-yourself is always going to be cheaper. However, the planning needs to be there, because if you do it and you don't anticipate, again, the power of the servers that you need, the number of inputs per device, the limitations of communication styles, this could get tricky quick. So again, planning, there's the 7 Ps, right? Prior proper planning prevents piss poor performance. So do it yourself versus kit and turnkey, it all comes down to planning and communication. Another aspect would be the specific style system versus a multi-application system. What is the system intending to monitor? So my former life, this telemetry system that we maintained looked at run cycles and alarm events, nothing more. We didn't care about water quality. We didn't care about the level necessarily. The weather, we don't care about humidity or pressure or temperature. Certain systems that have the ability, again, with more analog and digital inputs, can actually link up rainfall to run cycles. It can also backtrack to temperature and humidity. We have the ability to do door sensing, hydrant manhole sensing. Now, that again, monitoring versus control is another aspect. Is this a plant where we need control? That way, again, we can enhance the efficiency of the operators and dispatch them on more select calls where the SCADA itself can control a little bit more of the day-to-day operations. And then the final piece is a proprietary versus open system. Who has control of the device and the data? Who owns it? Does this specific telemetry system have the ability to integrate with a SCADA? Does your system as is have the ability to integrate with a SCADA? The advantages and challenges for the operators are, again, communication and education. What are we looking for? Cost savings, more defined maintenance program, and improved service, better, more efficiently managed networks deliver improved service to customers by ensuring consistent system performance, the pressure, the loss of service, and this references proper chlorination. Challenges, again, communications, cost, and security. Those are going to be a very common theme with all telemetry and all SCADA systems across the gamut of different vendors and different products. Reliable communication networks sometimes can be challenging. Again, you've got a lot of computers and a lot of servers that need to talk. When you're controlling, you've got two-way data traffic. You need somebody there that is able to understand what they're looking at. And if it's, again, not you, if this is a proprietary system that you're outsourcing, you need to be able to communicate what you see with these operators. Cost, this can run from very, very bottom dollar all the way up to an incredibly expensive system. Remote monitoring definitely is more affordable now than it ever has been, especially with the access to these high-tech controllers, the really compact pieces of equipment, the relays, the PLCs, that you don't have to replace existing panels. A lot of these companies are making chips or components that can be retrofitted directly into existing systems. And again, all of this, the shortcuts, the cost that we could either put in or take out, some of that could lead into cybersecurity if we take too many shortcuts, or if you just have a system that we haven't fully protected. We need to make sure, especially for the homeowners across the country, that especially on plant-wise, we need to make sure that security of the system is protected. So that's a huge thing to think about as you guys are looking at which system to choose. And the very first part is, what are you looking for? And we talked about it again. Is it cost savings? Is this scheduling wise for operators? Is this reactive to address existing problems, or are we preparing for future expansion? That is all going to push you into a potential style of system that you should be looking at first. Getting onto the data side of it, we talked about it a bit when we were explaining the benefits of a telemetry system. Each system is going to carry with it its own kind of unique flavor. Most telemetry and control systems are going to provide you these basic features: run data, alarm data, alerts, which could be, I'm going to call them semi-predictive, like run dries and brownouts and overpressures, or the ability to at least trend them to. You've got a rain flow sensor that tripped, you've got a door that's open, you've got a high temperature, high pressure alarm somewhere, tying in floats, and that could give you, hey, your mid-level float just activated and it shouldn't, and then you guys can use that data to kind of decide why. And then the reporting feature. So on the right, you're just going to see some screenshots of the way that some of this data is presented, be it in tables, be it in graphical format, be it in a combo, table and graphical. And then the notifications there for the bottom left picture, managing who is receiving notifications and which style. There's any features of the notifications that can be tailored. I fully believe that one of the most underutilized pieces of data that comes in through any system is run data. And again, I'm looking through very narrow glasses in terms of most of the systems that I've had a chance to interact with are single family residential pumps in a community. So a community of 500 people with 400 pumps or 300 pumps, being able to see that run data and compare one home's run data against another, not to try to figure out who's pooping more than who and being crude with that joke, but if there is a difference in 100, 200, 300%, that can really help a single homeowner figure out why their system isn't going to live long enough. It also is going to help control the flow leaving that home and coming into a given plant. So the run data, in my opinion, is incredibly important. We're going to go to the next slide, which is question 4, and I'm going to show you just what we can do with run data by itself, one of the most basic features. So Will, take her away. We're still there, you Will?
Oh, sorry about that. Typical SCADA telemetry alerts come in how? Please select one, A, B, C, D, or E.
All right, so this is where I should be saying, please don't say snail mail.
Exactly.
There it is.
Okay. Over 90% of you have voted. I'll leave it open for a couple more seconds.
While you guys are getting your last minute answers in, this presentation is only 17 slides, and I swear I could talk about telemetry and SCADA for the better part of 6 hours, but fortunately for you, we've got about 8 minutes left.
Thanks, Jim.
No problem. All right.
I'm going to close the poll, share the results. E, text, email, or phone call. Back to you, Jim.
Awesome. So yeah, pretty much every system that I've had a chance to interact with provides access to at least 2 of those 3. Most systems are doing all 3 these days. So in the slide before the poll question, I mentioned what I think is the most underrated piece of telemetry or SCADA system. That's just run data. So what you're looking at here is just 2 homes, both in the same community. I think they're actually about 2 blocks away. And this is a single family residential unit. And this shows approximately 1 year's worth of run data. So we're looking backwards historically. And honestly, we could have done this at the end of a 2-week period and seen just this exact same result with smaller numbers. And that would have been enough for me to cause an action. I would have identified it and then got on the phone with somebody to schedule a potential service visit to figure out how this is happening, why this is happening. This shows a normal home running by 8 cycles a day. So this specific residential unit, the targeted number of cycles is up to 30 cycles per day, 8 gallons per cycle. And again, the average expected residential home uses what, 200 to 300 gallons per day. So 8 gallons or 8 cycles per day is pretty low in terms of what we would expect that normal flow could be with 200 to 300 gallons. And that equates to around 2,900 cycles per year. So I used some basic stats that I found online, $0.0015 per gallon. So this means the Adair home is running at about $26 a year. Now, 2 blocks away, one of their neighbors, who they didn't know anything was going wrong, is running over 100 cycles a day. Like I said, we could have identified this in 2 days, not waited an entire year for it. But again, when you're managing a system, you have access to so much data, you're pulling through the weeds. This is why SCADA with an alert system built in, or some sort of like an analytical system that's built in that doesn't rely on an operator to be digging out this data, is worth its weight in gold, because this would have been identified incredibly quickly. This home had over 39,000 cycles per year at about $565. So the cost increase is just astronomical for a homeowner. And that's just using average water prices. I know there's certain parts of the country that water is a premium. And if this happened to be there, those dollar values could have looked a good bit different for the amount of water pumped through their system. And below, you just see a couple of screenshots of this specific system's user interface. It gives power reads, volts, amps, and watts, total cycles since the system was installed. as well as today's information. Then there's access to a few other tabs that track alarm history, individual pump cycle data with timestamps, messages if there are any, generally messages used by operators to say, I was out at this home on this date and here's what I did. That way there's a running record of service that's electronic forever. And then on the bottom, we got a little note about a running water toilet. Can waste thousands of gallons of water per month, which is about $200 unnecessarily tacked onto your monthly water bill. So $2,500 a year down the toilet. And again, the above scenario is an extreme case of a toilet leak. So last up, we again, I've been saying this a lot because it's the most important part about today's conversation is identifying what you need. With so many flavors of telemetry and SCADA to fit a myriad of applications, be it water, be it wastewater, be it whole home monitoring, the whole IoT smartphone of things, the smart home of things. There's so much selection. It's like going to a burger joint and having to pick between one of 300 different burgers. You know you're hungry, you don't know which one you want to eat. So figuring out what you want first is the very first step to figuring out a system that's going to give you those needs. So we've got systems that do as little as what the screenshot on the left shows, just basic output of performance data, cycles, runtime, gallons pumped. Then you've got systems as complex as the one on the right that are doing potentially salinity and chlorine monitoring, pressures, temperatures, cycle counts, system uptime, system downtime. You've got voltage monitoring and communications, real-time status, and how strong the cell signal is. Don't waste money that you don't need to waste. If you don't need everything on the menu, don't buy everything on the menu. There's a system out there that'll provide you with only what you want. And last up is just managing notifications before we slide into the conclusion section. So again, we've talked a lot about all this data that's potentially coming through. Well, if you don't have an analytical system that's kind of running as a side program that's managing the data for you, if you're relying on texts, emails, and phone calls to operators, make sure that you have them set up the right way. Certain systems allow a little bit more flexibility in terms of delaying the alarms that come in to minimize nuisance events, because I know the last thing that technicians want, that operators want, and that homeowners want is for somebody to show up at their house and potentially charge them money or cost money for something that wasn't really there. If this alarm happened and it was because the homeowner happened to be using a bathtub, a sink, and a shower all at the same time, that's expected. That's a momentary overflow or overfill of the system. So we overwhelmed the capacity of the pump. However, the pump is going to play catch up, evacuate the fluid, and we're done. There was no need for a call there. That's why certain systems allow delays to be configured. If the alarm persisted and an operator hasn't acknowledged it, certain systems will also allow a nag feature, or the operator will be re-messaged saying, hey, nobody has responded to this. I'm going to try you one more time. And the nag also works as an escalation. Let's say an operator doesn't respond, it can be escalated to the operator supervisor. And the supervisor can then decide on who to dispatch or how to dispatch. So figuring out as a management side of it, how to configure the notifications to provide the biggest benefit to both you and your operators, as well as the most efficient response to whatever the alert was generated for. And this one, high humidity. Well, if it's 94 degrees outside and 86%, maybe we don't care about that. That might be something we intentionally ignore, knowing that in a couple of hours, the sun will start to drop, humidity goes away. This could also be on a critical piece of equipment where we can't take the risk. This is where you guys have the power. Power starts with knowledge, figuring out what you want, and then from there, figuring out which system is going to give you the best result and how to set that system up for minimal effort for you guys going forward. So in conclusion, I 100% believe that every municipality, water plant, wastewater plant, even residential home will see a benefit by having a telemetry or a SCADA system installed. You're going to have reduced expenses, a higher operational efficiency, a longer MTBSC is a fancy term for mean time between service calls, and an all-around longer product life. Again, that said, circling back to the biggest point of the day, understand what you need. The more you know up front, the better you will be able to decide what you need going forward. Do you know where your inefficiencies live? What are your organization's goals? Those two questions are going to factor directly into a system that's going to fit your needs the best. And once you get the data, what are you going to do with it? Why collect it if we're not going to do anything with it? And that being said, consider that old adage, be careful not to be penny wise and pound foolish. Don't trip over a $500 bill to pick up a single dollar. You need to spend money and just make sure the money that you spend is going to give you guys the return on your investment. With telemetry, you guys can have a longer, healthier systems life. You guys can minimize your overtime, the nights and weekends calls. The public will be happier. There'll be no interruptions in services or minimal, because we always expect acts of God and acts of Mother Nature to occur. But systems like this can definitely help minimize the impact. Don't neglect the homework. Don't neglect network security. I really do appreciate you guys for tuning in to this. Again, this is felt like more of a sales pitch for me, and being a service guy, I'm not used to it, but this is a subject that I'm very passionate about. I've seen systems without telemetry, and I've seen them with it, and it's night and day difference. It can do so much for you, and hopefully this opened your eyes to some of the possibilities that exist out there. And you got my email, and you got Will's contact info. If you guys wanted to talk any more about this, we would absolutely be happy to.
Great, thank you, Jim. In the essence of time, we'll respond to all questions via email. I just want to thank you, Jim. Great job. Thank you all for attending. And please do not hesitate to email or call your local Siewert outside sales engineer if you want to discuss your applications in more detail. And have a great rest of your day. Thank you all.